All right, today we're going to talk about a piece of tech that sounds like it's straight out of science fiction, but it's very real. It's called Photon-Counting CT, and it promises to completely change how we see inside the human body. It's a huge leap forward, so let's just dive right in. And really, it all boils down to this one simple but incredibly powerful question. What if we could get images of our organs and blood vessels that are way sharper, way more detailed than ever before, all while using a lot less radiation? That's the promise we're going to unpack right now. So, to really get why this new technology is such a game changer, we first have to talk about the machine we all know, the conventional CT scanner. I mean, it's an amazing tool, don't get me wrong, but it's got some built-in limits that have been holding things back for a while. Okay, so how does a regular CT scan work? Well, it's kind of like a two-step dance. The X-rays go through your body, and first, they hit a special material, a scintillator, that flashes with light. Then, a totally separate sensor has to see that light and turn it into an electrical signal. You see that extra step? X-ray to light, then light to signal? That's where we start losing some really important information. You know, a really good way to picture this is to think of a simple rain gauge in your backyard. At the end of the day, it tells you how much rain fell, right? But it tells you nothing about how it rained. Was it a light drizzle all day or one giant downpour? Conventional CT scanners are just like that rain gauge. They just add up all the energy from every X-ray photon and give you one single number. And that old way of doing things, it leads to some real problems. The physical design of the detector creates these little dead zones that can't see anything, which wastes radiation and makes the image less sharp. And because it's just measuring the total energy, all the subtle details from low-energy photons just get drowned out. It's kind of like trying to hear a whisper in the middle of a rock concert. It just means blur your pictures and, you guessed it, higher radiation doses for the patient. So, this brings us to the big breakthrough, the aha moment. What if, instead of just collecting all the rain in a bucket, we could count every single photon? And not just count them, but measure the exact energy of each one. Well, that is the fundamental shift that changes absolutely everything. And this is it. Photon-Counting CT, or PCCT. It uses a totally different method called direct detection. An X-ray photon smacks right into a semiconductor and boom, that single event is instantly turned into a super precise electrical signal. There's no middleman, no flash of light, it's just a clean, direct measurement of that one photon and its energy. Let's go back to our rain analogy. If the old CDT is just a bucket, PCT is like this incredibly advanced weather station. It doesn't just count every raindrop, it measures the exact size of each one as it falls. So you get this incredibly rich, detailed picture of the storm, or, what's going on inside your body. So let's put them head to head, old versus new. We go from an indirect system to a direct one, from a clunky two-part detector to one elegant semiconductor. Instead of just lumping all the energy together, we are counting every single photon. And the result? A system that is way more efficient with radiation and just so much more powerful. Okay, so that's all the cool tech stuff, but what does this actually mean for patients, for you and me? This isn't just a small upgrade, folks. This is a potential revolution in how we find and treat diseases. Let's start with safety, because that's a big one. Check out this number. In one study, PCT cut the radiation dose by nearly 25%, a quarter. How? Because the system is just so much better at its job. It doesn't waste photons, and it can filter out all the electronic noise, so you get a beautiful picture with less radiation. That is a gigantic win for patient safety. And the detail, it is just staggering, because these new detectors don't have those dead spaces we talked about. The pixels can be way, way smaller, and that gives us ultra-high resolution. For the tiniest, most vulnerable patients, like newborn babies, this means doctors can now see incredibly small, complex heart defects that were pretty much invisible on older scanners. Now, let's talk about something that's basically a diagnostic superpower. Picture this. A doctor is looking at a scan. They see a bright white spot near a kidney. Is it a harmless bit of calcium in a blood vessel, or is it a painful kidney stone? On a regular CT, they can look almost exactly the same. But this is where it gets really cool. Because PCT knows the energy of every photon, it can tell the difference between materials. It knows the energy signature of calcium versus, say, the iodine in a contrast dye. So the doctor can literally tell the computer, hey, show me everything in this picture that isn't calcium. And poof, just like that, the calcium can digitally disappear from the image, leaving behind a perfectly clear view of the blood vessels. Or they can do the opposite and isolate just the kidney stone to figure out exactly what it's made of. And the best part? They get all this information from one single low-dose scan. No more follow-ups, no more guessing. So when you add it all up, the benefits are just immense. We're talking way lower radiation risk, needing less of that contrast dye injected into patients, and giving doctors so much more confidence when they make a diagnosis. It even cleans up the images, getting rid of annoying distortions and helping them see plaque in the heart's arteries better than ever. So if this is all so incredible, you're probably asking, why doesn't every hospital have one of these right now? And that's a fair question. Like with any truly game-changing technology, the path to making it the new standard isn't perfectly smooth. There are still some pretty big hurdles. And the biggest one, you guessed it, is cost. Making the special semiconductor crystals for these detectors is incredibly complex and really, really expensive. A single PCT scanner can cost well over $2 million. That's a massive investment for any hospital to make. And it's not just about the price tag. There are also some tricky little engineering puzzles to solve. For instance, what happens if two photons hit the detector at the exact same instant? Well, sometimes the system gets confused and counts them as one bigger photon. And because these scans capture so much more data, we're talking about massive files that need some serious computer horsepower to handle. These are the kinds of challenges engineers are chipping away at right now. But these challenges are being tackled because the payoff is just too big to ignore. And this quote here really gets to the heart of the whole revolution. We're moving away from images that just show us the structure of the body to images that also give us functional information. It's the difference between just seeing a car and actually being able to see what the engine is made of and how well it's running. The amazing thing is it's already starting. There are a few FDA-cleared systems already being used on patients. But the big question still hangs in the air. As the tech gets better and the price comes down, how long will it be until counting photons is just the way we do things, the new gold standard for everybody? One thing's for sure, the future of medical imaging is looking clearer than ever before.